Welcome back everyone to another video in our Calculus 1 series. In this video we're going to tackle yet another problem from our section on the tangent and velocity problems. My name is Ahmed. Let's get started. So in this problem we have the position of a car given by the values in this table, and we have t in seconds, which is time in seconds, and the position in feet defined here. And we have two questions to answer. The first one, we want to find the average velocity, and the second one, we want to find the instantaneous velocity. So let's start with the average velocity. We're going to have the average velocity for the time period beginning when t is equal to 2 and lasting for 3 seconds. Recall from our first video that average velocity was defined as the change in position over the change in time. And so here, I need to figure out what my time is. I know my initial time was 2 seconds. And they said that it lasted for 3 seconds. So how do I find my end time? Well, my end time is just the 2 plus the 3 seconds, because that's how long it lasted for. So I have the interval from time 2 to time 5. And so I already have my denominator for my problem. The change in position is given in the table at time 0 through 5. These are the positions. And so to write this out, we need the position at 5 minus the position at 2 over the time 5 minus 2. So we can look at our table for the position at 5 is 178 minus the position at 2 is 32 over 5 minus 2, which we can do is 3. My average velocity becomes 178 minus 32 over 3, which is 48.67 feet per second. How did I figure out the units for this? Well, my position is in feet, my time is in seconds, and so when we divide them out, we're going to get feet per second. And the units are extremely important in this problem, so don't forget your units. So 48.67 feet per second is the average velocity for the time between 2 and 5. Problem number B, letter B says, estimate the instantaneous velocity when t is equal to 2. Well, if I look at 2, only the position is given. Only the position at 2 is given. So how am I going to do this problem? Because I'm restricted in what information is given in my problem. I'm restricted by my table. Well, the instantaneous velocity is the velocity at one point in time, and it's t equals 2 in this case. I don't have the velocity at that one point in time. So, in this case, I have to estimate the velocity. How do I estimate the velocity at this certain point? Well, I'm going to take the two closest points to 2, which are 1 and 2, and then 2 and 3. If I calculate the average velocity from 1 to 2, and I calculate the average velocity from 2 to 3, then I can give somewhat of an estimate into what the instantaneous velocity at t equals 2 is. So let's do it. We have to calculate the average velocity from 1 to 2. This is equal to, again, the change in position over the change in time. So this is position at 2 minus position at 1 over 2 minus 1, which is equal to, the position at 2 is 32. The position at 1 is 10 over 1, which is equal to 22 feet per second. And I also have to calculate the average velocity at the time interval 2 to 3, which is the next closest point I have to 2. So that's going to be equal to the position at 3 minus the position at 2 over 3 minus 2. In this case, the position at 3 is 70 minus the position at 2, which is 32, over 1. And so we're going to do this, and you're going to get 38 feet per second. So now that I have the two average velocities, the average velocity from 1 to 2 and the average velocity from 2 to 3, I want to estimate the instantaneous velocity at t equals 2, so I'm going to take the average of these two numbers. And so the instantaneous velocity is 22 plus 38 divided by 2, which is equal to about 30 feet per second. This is the instantaneous velocity at t equals 2. And this should be about 30 because, again, it's an estimate. We don't have the exact velocity at t equals 2, but it's somewhere around 30. And so here I've answered my question. The instantaneous velocity at t equals 2 is about 30 feet per second by taking the two average velocities, 1 to 2 and 2 to 3. Now, you need to know that you're not always given a table with these problems. And so if you're calculating the estimation of the instantaneous velocity, given a function, for example, you can get closer and closer and closer to that value you're estimating. Because if I'm given the function y equals x, and I want to calculate the instantaneous velocity at 2, I'm not restricted to 1 and 3. I can get very, very close to 2. I can take a number like 1.9 to 2 and 2 to 2.1. So what you need to note here is that the closer you are to the value you're trying to get the instantaneous velocity for, the better your estimate is going to be, or the better the approximation is going to be. Here we were 1 unit away because that's what our table was defined as. But if you were given a function, you can get as close as you want because you can get all your y values from plugging them into your function. So just a side note for you to take into consideration while you do these problems. This is it for this section on the tangent and velocity problems. I hope this was helpful, and we'll see you in the next video.